Okay. So yes, this will be in English because my French is nowhere near where you guys are at. So I thought I would just go over a couple things that happened since the last meetup in the language. The three things I want to sort of just mention because they were kind of interesting and kind of big changes, at least for someone who's working on the language itself. In no particular order, I will talk about three things. One is the lib standard facade. I don't remember how to spell that in English or in French. The second thing I'll mention is the removal of tilde from many, many aspects of the language, and I think all at this point. I think it's not gone, but the libraries, at this point, it's on its way out. And then I think that CMR had the best word for this other thing. This is not a change in the language, it's actually just been a source of lots and lots of discussion recently. The so-called MutApocalypse. Okay, so the first one I'll do really quickly. So there was this big change to the internals of the libraries in terms of how we structured them, but a user of the language probably sees no change here at all, and I'm referring to the lib standard facade. So as a user of the language, when you pull in the standard libraries, you often start off your code with something like to pull in the string module from libstd. And it used to be, or rather from the standard crate. It used to be that the standard crate was, all the standard libraries were all packaged in one big crate, and there was implicitly, at the start of your program or your library, there was implicitly inserted a extern crate reference to standard. And that extern crate reference is still there, and standard is still there, but the structure of it now is that instead of having one big crate for standard, where all the code lives, instead now it's a facade over many smaller crates. And to be honest with you, I'm not quite sure in terms of the actual implementation technology what that means in terms of whether that you still end up with a huge binary for the lib standard crate when it all gets linked together. But in terms of editing the code, if you're someone hacking on the libraries, it's useful to be aware of this facade situation where now there's many smaller subcrates, and in particular there's one called libcore, where many libraries such as option or stir, others like vec or slice and whatnot, they have their core functionality in libcore, and then there's some extra stuff that gets bolted on by other traits and whatnot, and then everything gets pulled together into one composite whole for that piece of functionality like option or vec or whatnot, and then re-exported through standard. So the main thing I wanted to mention here is that there's been times recently, so I'm a bad person, and I don't use RustDoc. Like I don't even use I forget running RustDoc. I don't even look at the web pages for it. I don't like web browsers for some strange reason. I really shouldn't be working here. So I instead go straight to the code for things. And so there was this shift recently where I went to go look up what some function did. I wanted to see its documentation. I tried to pull up its source code, and I couldn't find the method because I was searching within the source code of libstd. It took me a while to realize that I needed to go look somewhere else for it. So if you're hacking on internal libraries, just be aware that this has been broken down into many sub-pieces, and you'll have to look in potentially a couple different places to find what you're looking for if you want to see source code. But that's all I'm going to say about that. It's just been a sort of interesting internal change. Yes? I believe the main reason this was done is that there's some pieces of functionality that we want to offer to end clients who don't want to have to assume certain other pieces of functionality. So for example, if you're implementing an OS kernel, you don't necessarily want to provide support for failure as a built-in thing that libraries can call out to. And so the reason for this refactoring, I believe the goal is that libcore will provide functionality that is truly like minimal in terms of it won't, nothing within here can call out to fail. And right. That's right. So that's exactly my understanding of why the motivation for this. Because some people wanted to deploy Rust in certain contexts, and they were unhappy that standard had so much stuff built into it that they couldn't readily deploy it into those contexts, embedded environments and whatnot. So this is meant to, libcore and then some of the other freestanding crates are meant to provide a path for those kinds of clients to pick and choose which crates they need and not have to pull in all of standard. So yeah, like I said before, I don't know if that means that everything ends up getting duplicated into libstd when it pulls everything in. I suspect that it's probably something where dynamic libraries don't get duplicated, and the statically linked ones, the rlib format, those probably get, code duplicated into the rlib for standard. Yeah, but I mean in terms of the object code that's generated. Yeah, no, I don't mean I don't think the code's not cut and pasted, obviously not. No, I was more concerned about just what it means in terms of your object code that you end up with. Of course, if you're, just making a final program, final binary, you don't care about any of those details. It depends. If it's if your goal is just to distribute an rlib just for libstd without any other freestanding libraries, then it's not a bug. It's actually what you want. I just don't know what the situation is now. I haven't tried to deploy it in such contexts. Okay. Next, the tildeing of things. I don't know how much history. I was just sitting here wondering to myself how much history to get into this about why tilde used to exist and why we're getting rid of it. I think just to make this nice and quick, I'll go over what the changes were, and then people can come up to me and talk to me about it afterwards if they want to get more into the heavy-duty details about why things were the way they were. This change, though, the main point I want to get across is that we are trying to make the language more uniform in a number of places, and to get rid of certain special case constructs. That's, if nothing else, the detildeing of certain constructs that I'm about to show you, hopefully I can bring across that there were certain things that were very special case things, and now they shouldn't be so much so. So this will be old hat to people who've been programming in Rust for a little while. So today there was, or until the very recent past, I should say, we had a rule like this. If you had a type, and by type I mean something that the compiler knew the size of statically. So if you had a type like I32 for a 32-bit integer, or a type like I64, a tuple containing two 64-bit integers, otherwise known as 128 bits of stuff right there. These things like this are types. They have sizes, and the compiler has certain operations it knows about for them. So these are examples of some type that I'll just label T. So these are possible T's, and there's many others. There was a rule in the past, very recent past, that for any type T, and by that I mean a sized thing that has a static size the compiler knew about, you could write down tilde T, and that represented a pointer, an owned pointer to a T on the heap, on a special portion of the heap that was dedicated to things that you could potentially send between different tasks. And this thing, since it was a pointer to some other size type. It always had, it itself was always just one word in size, and that's all it was. This isn't that special. In particular, the idea that this is an own pointer to T, some people got confused and thought, oh, tilde is the only way you express ownership in Rust. That's not true. In general, most types you write down in Rust, there's a notion of ownership for them. Like when I write down the type I32 and I allocate a stack of locals on my stack frame for that, I'm expressing ownership of that. I own the I32 that I have in that stack frame. Anyway, the point is, that was the notation for allocating some type like these or many others, structures, enums, etc., on the heap. Then there was a couple other interesting cases. There was, in particular, a vector type where, again, you wrote tilde and an open square bracket and then some size type here. And this represented some series of t's allocated on that heap again. And there's a pointer pointing to them. And then another special case was the own stir type, tilde stir. The thing I want to point out about this, and a point of confusion for many, many, many programmers, was that rule I mentioned about how you can go from a t down to this kind of thing, as in given some size type t, that implies that you can make tilde t. Many people in their heads, their mental model was, whenever I see tilde, I can take it off and I get a type out. I can deconstruct it the same way. I can look at that and mentally think of whatever is behind the tilde, whatever comes after it, as a type as well. And the problem with that kind of reasoning is these two cases exactly. When I say tilde t, where t is a size type, I knew for some t what the particular size of it was. For these two cases, when you take off the tilde, you don't know how big that thing is. The compiler does not know how many t's there are here, and it does not know how big your stir is. So there was a problem that we had in terms of explaining the language to newcomers, because these two were special cases. And for the most part, we got by for a long time by just saying, they're special cases. And a big problem with that is that when you had some people trying to explain, you don't need to use this form, tilde t. In fact, you probably should avoid it, and you should avoid tilde. People heard that and said, wait, I'm supposed to avoid these two things? And then the response was, no, I don't mean that tilde. I mean this tilde up here. And it's very confusing to have that kind of conversation. So, for many reasons, but I like to think of those as being the ones that I can really get my heart and soul behind, we've shifted the language a bit so that we've gotten rid of these tilde constructs. Instead, in our brave new world, instead of writing tilde t as a type, and likewise, the way to write expressions of this type was to say tilde and then some expression. For example, tilde 3 or tilde open paren 1 I64 2 I64 as examples. In our brave new world, what you write instead for the type is box of t, because it represents a boxed thing on the exchange heap. And for the expression format, you write a lowercase box and then the expression. There's technical details for why there's a keyword here. This is actually a keyword, box. I don't want to get into it right now, except that the simplest answer I can give you is that this is our path going forward for supporting placement new type things. I mean, it already gives us the very literal meaning of placement new as originally written in C++, but we want to be able to override it and have special behaviors the same way C++ offers for certain types. Lots of details I don't want to get into. Did you have a question, Simon?
Yes. Does it mean that in the future, lowercase box does not always mean uppercase box?
That's correct. my understanding is that I believe that I don't know the exact plan going forward in terms of whether these two will be tightly intertwined, but I definitely know that this format, as written here, yields this kind of thing, and then there's a different form that would look something like box, open paren, and then the special type, a description of the type that you're allocating into, or the value of some type you're allocating into, and then the expression here. And I believe this can yield something that's not a capital B box, but not 100% sure of that. It might be that the goal is that, in fact, maybe that yields a box of T and there's an optional type parameter here signifying the distinction. I'm not 100%, I don't remember, to be honest, what the current plan is there. But it doesn't matter because we don't really have good support for this format yet anyway, so pretend I didn't say anything about that, and just keep in mind that this translates to this direction. So if you're looking at old code bases, you know, if you go to somebody asked me recently about my ncurses library, and I haven't upgraded that in months. Like I haven't tried to compile it against Rust in months. So, you know, there's lots of old code lying around up there that'll make use of these three things. So if you see this, it gets turned into box of T. If you see this form, the tilde with a square bracket, that gets turned into a vec of T. And there's other slight distinctions, like the representation of this is, the way it was represented was a single word pointing to a structure on the heap that carried the capacity of the vector, its actual allocated length, or initialized length, and then the actual payload of the series of elements that it points to. So this was one pointer pointing to something that had 3 plus k words on it. This one here, it shifts things around a little bit so that this thing is 3 words long. It carries its own, yes, this carries its own capacity and its initialized length and a pointer to the payload. There were details about why we did it this way. The simplest one is that it's expensive to allocate. Even allocating a zero-sized version of this is expensive because you've got the pointer and you have to actually allocate on the heap something that's 3 words long. So if you made an array of empty vectors, you had to fill, for every one element on the array, you had to allocate a separate tiny object. And with this version, what you do instead, if you want to make an array of empty vectors, you just make the array and initialize it all at once. And you don't have to make individual allocations for each payload because you use null for the zero initialized things. That's an example of why we did this way. And then for stir, the current story here, and this is still a source of ongoing discussion, is what to name stir. Because the part of the story that I haven't talked about here is for each one of these 3 types, where this is the owned thing on the heap, this is the owned vector, owned global vector, and this is the owned, or this was the owned global vector, and this is the owned global string, there was a corresponding borrowed type that uses ampersand T, a slice type of ampersand bracket, and a stir type of ampersand stir. So the question now, for some reason it was really easy to do this renaming in terms of getting people to sign on to this shift, but with stir, I just said this, but I'll write it down. Ampersand T, or tilde T, there's a corresponding ampersand T for an alias, a shared alias borrowed thing it points to. And likewise, there's a borrowed slice. And finally, there's a borrowed string slice. The question is, okay, we found the translation of this to box. We found the translation of this to vec. And in each of those translations, we can leave this the way it is, and we can leave this the way it is. Those make sense as specialized syntax. Everyone's happy with that. For stir, the question is, what should we call this over here on this side? What should stir become? And there is a big thread on GitHub with lots of ideas and lots of proposals. I'm not going to get into which ones were sane and which ones weren't. I'll just tell you where we are right now today and say it is absolutely temporary, as in the plan of record is that it's temporary, and if we happen to keep the way things are today, it's for no good reason other than inertia. So right now, tilde stir gets translated to something called stir buff, meaning that it's a string that's got an allocated buffer of stuff, and thus if you can grow it by writing into that buffer, as opposed to a slice where you can't grow a slice, you just have, it's a pointer into some pre-allocated space, and you don't have any control or knowledge about what lies outside those bounds. So a slice you can't grow or shrink. So that's how those things are translated now. And finally, the MutApocalypse. Now I'm debating about whether I really want to get into this that much. Just even writing down the stir buff thing, like I thought that debate was hard. And the MutApocalypse has sort of become even worse. I'll quickly outline at least the big ideas of what's happened and what was proposed, I guess. So nothing's changed. So everything I've talked about so far are changes in the language since the last time we met a month ago, I think, roughly. This is not a change that's happened in the language since we met. It's a discussion of a potential change in the future, but it's possible that nothing will happen and that we won't change anything. That's one of the options on the table, is to not change this at all. So there was a blog post that Nico made where basically Nico pointed something out where he said, we currently write down let mut x equal 3 to mean that this is some mutable state, a mutable stack slot that we can reassign stuff to. And we might also write let y equal, we could borrow a reference to x here, so we could actually, let's say, borrow x. In fact, we could mutably borrow x as well. We can write at mut x, which means that y is now a mutable pointer to the stack slot for x. And the point is that in Nico's blog post, he made a point of saying that there are some problems that come up where if you have he gave us a couple examples. One was he gave an example of refactoring code where you started with some code that looks something like this. Maybe there's a let z here without the mut notation. He first noted a situation where if you try to refactor your code and introduce a subroutine somewhere, there are some situations where you end up wanting to express that there is unaliased access to one of your arguments over here. So you might want to say that I have an unaliased pointer to y right here. And the problem is that if you just say ampersand y, that doesn't say that it's unaliased. That in fact just says this is a shared reference to y, and a shared reference to y is one that many people could have their hands on, and thus you don't have the right to mutate x through it. So that's not good. You can't express unaliased access that way. And if you say ampersand mut y, problem there is that the original programmer didn't write let mut y, they only wrote let y, and so you can't take that kind of, you can't do that kind of borrow either. So that was a problem that Nico noticed, and in discussing it, he pointed out that this idea of expressing unaliased access while still immutable access, and immutable in the sense of I can't change y itself. I can change if y points to something mutably, or if y is a structure that has a field that points to something mutably. If I have unaliased access to that structure, I still have the right to mutate things it points to. I just don't have the right to mutate the thing itself. So he pointed out there's this idea of immutable but unaliased access. And he gave a couple different potential names one could use for this thing. I'm going to say ampersand unique for now, even though, perhaps because I know that Nicole doesn't like it. So this would be a way to express, but there's lots of other ways that you might write this. Ampersand my, ampersand only. The idea is to try to express unaliased access and focus on that aspect of things, and not so much on the mutability aspect. So this is sort of an interesting notion to try to pull out, this unaliased access to data. And then he pointed out in his blog post, in the next example he gave involving closures, he actually pointed out that the way we implement closures today, we already have support for this kind of construct in the language itself. Not in the language, but in the type system for the language. We already have it implemented. So this led Nico to ask, are we doing ourselves a disservice by having this distinction, by focusing only on the distinction between immutable and mutable, when this language is so much about whether something is shared or unaliased? And the mutable-immutable distinction may not matter so much as focusing on shared versus unaliased. So Nico put forth the proposal to get rid of the mute keyword. He had a bunch of proposals that he put up there. The one he said was, maybe we should just get rid of the mute keyword, and all variables you declare are implicitly mutable, and the control over whether you're allowed to mutate it or not, the borrow checker can figure out based on what you've done with it, whether you've actually given up shared access to it, and thus it should be treated immutably, or if you've kept unique access to it, if you've kept unaliased access to it, and thus you can mutate it safely. So one of his proposals was to just get rid of the mute keyword, to stop saying let mute. You'd still say ampersand something. It might be ampersand unique, it might be ampersand my, but just focusing on that part of things. What then happened was the world crashed, because a lot of people just focused on the part of the proposal that said, let's get rid of let mute. And a lot of people said, oh, but I really like saying this distinction up front in my let bindings. And then some of those people who were arguing for that, saying, I like saying let mute X and let Y without a mute, they made further claims about how they know that Y and Z are immutable because they don't have the mute keyword there. And this led to some further discussions where people pointed out that the Rust language doesn't stop you from making certain kinds of types where you don't have the mute keyword, but there's still some mutable state owned in that part of the system. In particular, the cell data type is one where you can have some sort of structure here. Inside of it, there can be a cell of integer. And what essentially happens is that I can pass Z around with a shared access to it, and people who have that pointer to Z are free to mutate the cell. It's a special type. It's implemented with unsafe code, but it ensures that you still can't get data races in the sense of you can only put certain kinds of types in a cell, basically. So it ensures that you aren't going to get into certain kinds of problems that you would hit if you just allowed unfettered construction of such things. So the community at large, a lot of people invested a lot of time learning about this problem and then proposing counter proposals for trying to basically get rid of this case. They really wanted some way to say, no, when I write let Z, or something like let Z, I don't even want to allow a cell in there. I want to ensure that people don't even have that kind of what they thought of as hidden mutability behind the scenes. So that was one branch of the conversation. And then another branch of the conversation was people pointing out that what we have is fine if you explain it right. Yeah, there's these details that Nico pointed out, and the thing with the closures is troubling if you assume our current approach to closures, but they pointed out that our current approach to closures isn't necessarily what we want long-term anyway, and that a shift to a different kind of closure, an unboxed closure where you don't implicitly take references all the time, and instead you copy values in or move values in much more often, gets rid of the problems that Nico was pointing out. So that's sort of a quick, or attempt at a quick overview of this space of discussion, because there's a lot of noise about it, and it's got a lot of people a little tired. I mean, the Reddit page for Rust I noticed today said something like, Rust is tired of talking about mutability. They changed the title page for it because they just got frustrated with this discussion, how many subreddits or how many self-posts were coming up of people addressing this question. So my take on this is that I don't know what's going to happen. I was personally most interested in a side thread of Nico's discussion, which was the idea that since we already have support for this type anyway, why don't we add support for it in the language without getting rid of anything else we have? And I've been looking a little bit at that, but the reality here is I don't want to complicate the language too much, which is a big fear that people have. Historically, Rust had many pointer types and a lot of syntax for different pointer types. There was the @ for garbage collected storage, there was the tilde for owned stuff, and there's still the ampersand for a borrowed reference. And we've come quite a ways to try to reduce the number of syntactic concepts and trying to make them all look like library types. And the question is, with the introduction of a type like this, does it actually buy you anything? Even Nico didn't want to just add unique without getting rid of something else. He stated in his blog post, he said he wanted to consider getting rid of let mute and replacing ampersand mute with something else. But even he said, of like the 4 options that he put down, he was like, if the one that he was arguing for didn't pass muster, then he didn't want to change anything. So my suspicion is, given how much commotion there's been in the community, is that I just wasted all of your time talking about this because probably nothing's going to change. But nonetheless, I say that, half kidding, because there are details here where a lot of people don't necessarily know about the things like you can have mutable state behind something that's not marked let mute. It's obvious once you've worked with the compiler for a while that it's possible, just because the compiler internally uses tricks like this all over the place. But still, it's worth being aware of that some of the reasoning principles that you might think you can apply if you're just somebody who knows about the lambda calculus and assumes, oh, functional programming, this kind of looks like functional programming, I guess I get referential transparency and I can just substitute equals for equals. And the answer is no, we're not at that point, and I don't plan for us to be at that point. These markers are about something a bit more subtle than that. Okay, so that was sort of my overview of some big, crazy things.
Maybe what we will get out of this discussion is things that need to be added to the tutorial or some other documentation?
I think that that's the big story here, is that our documentation and tutorial still need improvement. I think, I haven't looked recently, my understanding is that there is treatment of this distinction of what's called interior mutability versus inherited mutability. It is treated in the tutorial, but I haven't looked at that section recently. I'm not sure if I ever looked at it. Like, it was added after I'd already read through the tutorial, in state at that point. So my suspicion is that there's 2 things I think that might happen. One is that the documentation needs to be improved, but also I suspect we might see a shift in the terminology we use internally. I suspect that part of the problem might be that we're using terms that, like, even just saying interior versus inherent, those are 2 words that sound very similar to each other. So maybe we'll see a shift where we start choosing better words for things, or maybe not. I don't know. But yeah, I think the biggest lesson here is about education more than anything else.
What's the next big thing, maybe? Okay, I need to eat the microphone. Oh, it sounds
Yum
better.
yum.
Yum yum. Do you know what's the next big thing coming? Like, I know there are big plans in the Rust land, and so do you know what you're going to present next in a month?
I'm not sure, but if I had to put my put a guess on something, DST is really close, I think.
Yay.
I think Nick's working on it. I think it's what he's spending all his time on in New Zealand. So DST stands for Dynamically Sized Types. And in fact, I can refer back to an earlier slide. Remember when I was talking about this distinction about T being something that the compiler knew about the size of, and that these two things without the tildes are things that the compiler doesn't know the size of? So DST is meant to unify these concepts in a way so that in the language we'll actually have a notion of the class of unsized types, the ones whose size is only known at compile time, and the size types, ones that the compiler knows the size of statically. And the reason that this is really important is that, so these are two interesting special cases when you take off the tilde, but the big one is trait objects. Because Nico noticed that, this is kind of interesting that these two things have a size, or sorry, these two things have a dynamically known size, and you could represent them. I mentioned before, I think, that the current representation for these two things, or at least this first one, I think the second one as well, is just a pointer to a capacity, length, and the payload data. What Nico pointed out was that with some fiddling around, you could switch things around so that for an unsized type behind one of these sigils, you could represent that as a pointer to the payload plus an additional word on the pointer itself that represents some metadata. In particular, for arrays and for strings, it would represent the length of the thing. But the cool part is that for trait objects, that extra metadata word would represent the vtable to do method dispatch. So there's a sort of beautiful unification of ideas there where you can take any size t and put it behind a pointer sigil like ampersand, and you get out a single word thing. Or you can take an unsized thing, which is an array or a stir or a trait on its own, and put it behind a pointer sigil, and you get a two-word thing, a pointer to the payload, and then the metadata word. So that's DST in a nutshell, dynamically sized types. And the important thing is that adding that to the language will make it so that right now, if you want to implement some methods or some traits for a type, you often have to duplicate code where you have to write down, make one implementation for box of array or for tilde array, and make another implementation for a borrowed array, even though the actual code you write down for all the methods is the same code for both cases. The only reason why you have to make the two separate implementations is because the impl form needs to have impl trait for type, as in t, as in a sized thing. And Nico's proposal for DST lets you actually express impl trait for both size t or for an unsized t. And so you get to not repeat yourself and just write down the impl once for all possible kinds of arrays, be they owned arrays or slices to arrays, and hopefully also for other kinds of smart pointer types. That's the big win, is that we are looking forward to having many kinds of smart pointers in the language, reference counted, garbage collected. They'll all be expressed using either box or something like box, GC of t, RC of t, etc. So you don't want to have to rewrite all your impls for every single pointer type variant. And DST is part of the story that gets us there. Okay. Simon?
So I have two related questions. You said the reason we made this change to move away from tilde everything was the confusion between tilde t with a size t.
It was one reason. Yeah.
Okay, that was one reason. And the other two? Does the same confusion not exist with ampersand?
I think that once you have DST, there's a uniform story. So the reality is that DST gives you a uniform story for all this stuff, in a sense. So I said before how a pointer to a size thing becomes one word, and then a pointer to an unsized thing becomes two words. And so what you'll see is that you'll explain this construction, and this construction, and this construction via DST. You'll say, in this case, you decompose it as a borrowed pointer to what's this thing? Is it a size thing? Okay, then that means you use the size type path in terms of your reasoning about what this does, in terms of it mapping to one single word of memory, and it's a pointer just to that thing. Versus the unsized cases where, oh, you have ampersand and you have brackets here, and that means that, and it's brackets without an explicit length. So you'll explain that by saying it's an unsized thing. So the important detail there is that there's a unified story where this becomes one word and each of these becomes two words. And in one version of the proposal, we actually kept all these syntaxes. And in a sense, they'll still be around after DST lands. In particular, I said that tilde t goes to box of t. My understanding is that you can still you could take an array and do box of array. And you can take a stir and do box of stir.
In DST.
In DST. The problem is that they're not very useful because the way DST dictates things, what you end up when you do box of the array or box of stir is you end up with a pointer to the payload and then another word for the metadata, which will just be the length of the thing you have. And you don't necessarily have the ability to grow or shrink it easily. The vec and strbuff representations are special. These are specialized representations for these two special cases because you want both the capacity and the length, because you want to pre-allocate extra space to grow and shrink within. If you do it with box, the DST story doesn't give you the two words, doesn't give you the length and the capacity. You only get to have one of them. And so the answer there is that you could, I believe you'll be able to write it down. And there was debate internally for a long time as to whether it would be useful to be able to write it down and whether our libraries should still continue to try to push to use the equivalents of these types. But at this point, the community has pushed back enough and presented a pretty compelling argument that you won't want to use box with array or stir in most cases. In most cases, you'll want to use vec and strbuff. The most compelling counter case, the most compelling counter argument that I have to that, so this is 3 words, and this is 3 words, and this will be 2 words for an unsized type, and likewise, this will be 2 words, and this will be 2 words. The only compelling case I have to use box of t with an unsized thing is that there are rules that let you take an array of these things, like I'm talking about a vector of boxed vectors or a vector of boxed strings. There are rules that let you take that and immediately transmute it to a vector of borrowed vectors or a vector of borrowed stirs. Because keep in mind, this is 2 words, this is 2 words, so an array of length k is going to be k times 2 words long. You can't immediately transmute an array of vecs. An array of vecs is going to be k times 3. You can't just take that and immediately transmute that to a borrowed array of borrowed vectors. It doesn't work because the sizes don't, the layouts don't match up. You have to do something to convert each one of those entries from a 3-word thing to a 2-word thing. So this was the best thing, the best reason I had to push to keep using box even with these 2 cases. And it's pretty hard to support. It's a question of whether that case arises sufficiently often to warrant making your whole standard library have to deal with these cases. I don't know if that answered your question. It was probably way detailed.
My second question was going to be, if this confusion is fixed by the DSC, why do we still want to make the change? But I think you just answered it.
Yes, we definitely, I think, want vec and stirbuff, although, like I said, there was some debate internally about it. You want them as concepts regardless. The question is whether you want to ever encourage use of box of this and box of that. You definitely want vec and stirbuff. Even if you had box of this and box of that, you want vec and stirbuff as concepts. What Rust used to do, since it recognized that box of vec and box of stir are not useful, and that these two things are useful, the conceptual hack that it used was to use the same notation to represent these very different things. They basically, Graydon Hoare, I think, recognized that these two things are so useful, let's give them a really sweet sugar. But the problem with that reasoning is that it makes it really hard to, one, learn the language, and two, it complicates things like DST, where you'd really like to be able to have a uniform treatment for everything on the other side of the tilde, or everything on the other side of the ampersand. Okay. Any other questions? Great. All right.